All right, MathCounts, here we go. We got a similarity stretch for this week. So I wanted to show you some different problems that you'll probably come across, really problems that are pretty common for MathCounts with similar shapes. Now, in order to understand what we're going to do here, we have to remember that similar shapes are shapes that they have the exact same angle measurements, but they're not necessarily congruent to each other, meaning they're not like the same exact size, they're a similar size, which means that the sides are going to be proportional to each other. So there's a proportion in the sides, but the important thing here is we can tell if they're similar if the angle measurements are congruent to each other. So it's kind of like a shape has started off small and then we just blew it up a little bit. Okay, that's what a similar shape would be. The angles would stay consistent. They'd be congruent to each other, but the sides would be in some kind of scale factor. All right, so let's look at this first one. So the first one has what we call alternate interior angles, and this is where we can tell which sides correspond to which sides. So in this one, this angle and this angle are what we call vertical angles. Vertical angles are always congruent to each other. And then we have this parallel line and this parallel line, and we have something called alternate interior angles when you have two parallel lines and lines that cut across it called transversals. So alternate interior angles means different sides of the transversal, and interior means both inside these two parallel lines. So we would say that this angle here is alternate interior angles with this angle here. And then you could do it the other direction as well. These two parallel lines have this transversal, and then these two would be considered alternate interior angles. Different sides of the transversal. This one's on the top of the transversal, this is on the bottom, but they're both interior of these two parallel lines. So this angle corresponds with this angle. So I can see here that since all of the angle measurements are congruent, that these two triangles have to be similar to each other. Therefore, there is some kind of proportion between the left triangle and the right triangle. Now I can see what the proportion is here. 5 is between the angle tick mark of 1 and 2, and 8 is between the angle tick mark of 1 and 2. So if I compare the left to the right triangle, they should be in the proportion of 5 to 8. So now I can use that proportion to solve for all my missing sides. So let's start by solving for, let me get a pen here. Let's start by solving for x. So my ratio is 5 to 8, comparing left to right. X is from the left one, so I would put that in the numerator. And then the corresponding side to that one, the one that matches it between angle 2 and angle 3, angle 2 and angle 3, that would be 12. And now you can just use cross products to solve it. 8 times x is 8x, 5 times 12 is 60, and then you can divide by 8 on both sides, and you would get something, 60 over 8, which reduces to 15 over 2, 7.5. All right, then you can do the same thing for y. What color should I use for that? Oh, we'll use orange. So 5 over 8 equals, y is from the right triangle. I put the right triangle in the denominator, so I'm going to put y up here. And then y is between 1 and 3, 9 is between 1 and 3, so that's what it corresponds to. And then you can just do cross products. 5y equals 72. And then y is equal to, let's see, 5 goes into there once with 2 left over, 14.4. Yeah, I think it's 14.4. All right, next one. Corresponding angles where a shape is on top of another shape. So we've got a big triangle with a small triangle on top of that. Now on top of this, it says that these two angles right here are right angles. Therefore, this side must be parallel to that side. So we already have one angle that's the same on both of them, angle C. Angle C is the same angle in the big triangle, and it's the same angle on the small triangle. So I'm trying to prove that these two shapes are similar to each other. So the next thing that I would say is, okay, I can now say that angle A is the same measurement as angle D, because these are what are called corresponding angles. Corresponding angles is when you have two parallel lines with a transversal. They're on the same side of the transversal, so both of these are on the bottom of this transversal. And then one angle is interior and the other angle is exterior. So these are corresponding angles. And then we already know that these two angles are congruent because they are both 90 degrees. So these two triangles have to be similar to each other. They have the same angle measurements, they're just in a different proportion. So let me give you some numbers for this one so we can work some stuff out. Let's say that this is 10 and this is 20. Let's say this is 5. I'm just making up stuff. I'm going to say this is 18. I'll make this one X and this one Y. All right, so if I wanted to set up a proportion between these two triangles, let's put the small triangle on top and the big triangle on the bottom. Doesn't matter which way we do it. So here I've got this side, 10 is between one angle mark and two angle marks. So from the small triangle, that's 10. The big triangle between one angle mark and two angle marks is 10 plus 20. That whole side is what corresponds to this one. So I can see the big triangle is 3 times as big. So when I reduce this, the proportion is 1 to 3. The bigger triangle is 3 times as big. So let's say I want to find x. X is from the big one. So I would put x in the denominator. What corresponds to x on the small triangle? Well, 2 and 90 degrees, 2 tick marks, 9 degrees, 5 does. Now you can use cross products, x is 15. If we wanted to solve for y, we got 1 over 3, small to big. We got that from our ratio up here. We call it a scale factor. So I can see that I got a ratio of 1 to 3. Y is from the small triangle. And then the big triangle is this whole side. That would be y plus 18. So y corresponds to y plus 18. Cross products, I get y plus 18 equals 3y. I subtract y from both sides. I divide by 2, and we find out y is 9. All right, last one. If we've got what are called inscribed angles. So inscribed angles are these angles out here. Inscribed angles just means that it's an angle that is touching the side of the circle. I've got inscribed angles, and just like the previous problem, I've got vertical angles. These two angles are vertical angles, so they have to be congruent to each other. Now, these two inscribed angles are the exact same measurement, and here's how I know. If I follow this angle out, this angle covers this portion of the circle, and then this angle over here covers the exact same portion of the circle. Therefore, inscribed angles are congruent when they cover the same section of the circle. So since this angle covers this part of the circle down here, and this angle also covers that same section, these two angles are congruent to each other. And then these other two inscribed angles, if you follow them out, they both cover this top part of the circle here. So this angle here is the same as this angle here. So now I can see that this side corresponds to this side corresponds to this side, and this side corresponds to that side. Let's give it some numbers and see if we can do some solving here. So let's say that this side is 10 over here, this side's 15, this side is 8, and this side is 6. I made it a right triangle. Didn't mean to do that. And this is x and this is y. So at this point, I would look for my scale factor. And let's do left compared to right. So this side is between 2 and 3. This side is between 2 and 3, so they correspond to each other. So 10 over 15. So the scale factor, the proportion that these two are in, is 2/3, just reducing it by 5. So now if I want to solve for, let's say, x, I would start with 2/3, which is a scale factor. X is from the right side, so I'd put x in the denominator. And x corresponds to 6 because they're both between 1 angle mark and 2 angle marks. Cross products, 2 times x is 2x, 3 times 6 is 18. Divide by 2, x is 9. Let's solve for y now. Start with your scale factor, which is the proportion between the two triangles. Y is from the bigger triangle over here, or the right-hand side triangle. So I'm going to put y in the denominator. And y corresponds to 8 because this is between 1 angle mark and 3 angle marks, 1 angle mark and 3 angle marks. So they correspond to each other. So we would put 8 on top. Now we do cross products. We get 2y equals 24. Divide by 2, and y is equal to 12. One last thing is you're doing this, what's it called? As you're doing the stretch. Sorry, it's early in the morning. So as you're doing this stretch, just remember that when you talk about length, area, and volume, that if you've got a ratio of 2 to 3 in the length, area is in units squared, volume is in units cubed. So if the scale factor between two shapes is 2 to 3 with their lengths, the area will be the square of this, 4 to 9. So if their length scale factor is 2 to 3, their area scale factor is 4 to 9. If their length scale factor is 2 to 3, their volume scale factor is going to be 2 cubed, 3 cubed. So remember that, and like if you're talking about weight, weight is usually going with volume. If you're talking about like paint on the outside of the shape, that's usually talking about area. So these are your different scale factors. Now, if they start you with volume, you're going to have to take the cubed root to get back to the length scale factor. You have to take the cubed root of both of these. If you start with area, you have to take the square root to get back to here. All right? That should get you through the stretch for similarity. Math hard. See you guys later. Bye-bye.